The limiting reagent or limiting reactant is the compound that's one of the reactants, either water or La2O3, lithium oxide, that you have abundance of. It's kind of like when we did 2 weeks ago when we looked at s'mores as an example. If you have 3 chocolate bars and 2 graham crackers, how many s'mores can you make? You can only make 1 s'more because you only have 2 graham crackers, but you do have 3 chocolate bars. So the limiting reactant or reagent is the graham crackers because you're limited on how many s'mores you can make. So the excess reagent, the one of the reactant that you have more of that won't react all the way, would be the 3 chocolate bars because you don't have enough graham crackers for it to chemically bond to form the s'mores, which s'mores aren't chemically bonded, but in these chemical reactions there is a chemical bond. So in these reactions, like when we did stoichiometry, I only gave you like 1 compound starting with so many grams, and you're trying to figure out how much you need of like the other reactant or of the product. But in this case, if you had 2.5 grams of lithium oxide in like a beaker and you have 5.2 grams of water in a beaker, which one will be used up all the way? Will water be used up all the way, or will lithium oxide? The one that will be used up and react and form the lithium hydroxide will be the limiting reagent. So that means the other compound, whichever one it is, you'll have leftovers of. Because in chemistry, compounds will bond in a certain ratio. It's not like all of this water will bond with all of this lithium oxide. There's a certain ratio, as you can see with the coefficient. There's 3 molecules of water right here that will bond with 1 molecule of lithium oxide. So they bond in a certain ratio. Just like when you make s'mores, you'll have 2 graham crackers per 1 chocolate bar. So that's what we're trying to figure out. To do this is like doing 2 stoichiometry problems. You're going to take how many grams of water you have, and you're going to figure out how many. You can just go to moles of lithium hydroxide. You can go all the way to grams and see how much you'll make of grams, but that's one more step, so just go to moles. So you're going to convert 5.2 grams of water to how many moles of lithium hydroxide. You're also going to do that with lithium oxide. You're going to figure out how many moles of lithium hydroxide you'll get. So the one that you will get the least amount of moles here, the least amount, will be your limiting reagent. So that means if we converted water and we only got 2 moles of lithium hydroxide, and then if we converted 2.5 grams of lithium oxide and we got 4 moles of lithium hydroxide, you will only make 2 moles of lithium hydroxide because you only have enough water to make 2 moles of lithium hydroxide. So I'll show you what I mean when we do the calculation here. So we are converting grams of water to moles. First thing you always have to do is convert. If you have grams of the compound you're starting with, you have to convert it to moles first. Okay, so this is water. So make sure you have a periodic table handy. I'm going to add up 16, which is oxygen, and plus 2 more for hydrogen, which is 18 grams. And then once we have moles, now we can do the mole ratio, 2 to 3 ratio right here to go from water to lithium hydroxide. So since I have moles of H2O on top here, moles of H2O goes on the bottom here, and then you put moles of lithium hydroxide on top. So the mole to mole fraction is when we look at the coefficient. In front of lithium hydroxide, there's a 2. In front of water, there's a 3. So then we go to our calculator and we take 5.2 divided by 18 times 2 divided by 3. You get 0.19 moles. So if we were to use up all of the water, that means we have enough lithium oxide to react with all that water. We would get 0.19 moles. Let's see what we'll get if we reacted all of the 2.5 grams of lanthanum oxide. So first thing you have to do is convert to moles. I think a lot of these compounds were in last week's calculations. So if you want to look at your last week work, then maybe you don't have to look up the masses again. So lanthanum is 138.9, so I'll round to 139. And there's 2 of them, so I'll times it by 2. And then oxygen is 16, and there's 3 of them. So 16 3 times. It's 326. Okay, go get the remote. So that's the mass of lanthanum oxide. Now we have moles. So that's when we can go from moles of lanthanum oxide up here to moles of lanthanum hydroxide. So that's when we use the mole ratio. So remember, you put lanthanum oxide on the bottom because it's on top right here, and then lanthanum hydroxide right here. And then you plug it into your calculator, frozen. Okay, in your calculator, you'll have 2.5 divided by 326 times 2. That's going to give you 0.015 moles. So, let's see. The least amount, which one's smaller? This is 0.19, and then this is 0.015. So this is the smaller amount. This is the actual amount of moles that you'll make of lanthanum hydroxide. So that means lanthanum oxide is our limiting reactant. So that means that all of this 2.5 is going to be used up. Not all of the 5.2 grams of water is going to be used up because it doesn't have enough lanthanum oxide to react with all of it. So I know it doesn't ask for this, but this is the excess reactant. This is what you have excess of. So basically, this is lanthanum oxide will be your 2 graham crackers, and then water will be your like 5 chocolate bars. You only can use 1 chocolate bar of water, but because you don't have enough graham crackers or lanthanum oxide to react. So in the joke up above, you're to use this symbol for number 1, La. So that's what you write down for number 1.